So today we're doing 4.4, counting rule. And so the first example we got is we want to count the number of ways there is to toss a coin and toss a coin and roll a die. Okay. So when you toss a coin, you got two possibilities. You got either head or it could be tails. And then when we roll a die, there's 6 possibilities. So we could get heads, and then we could get either a 1, a 2, a 3, a 4, a 5, or a 6. And then maybe we flip tails first, so then we could get when we roll the die, we could get a 1, a 2, a 3, a 4, a 5, or a 6. So if you want to count the total number of possibilities, then we got to count the ends of the branches. So then there's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 different ways. So 12 different ways. Okay. So then we want a slightly easier way of doing this so we don't have to do a tree diagram every time. So if we think about how many ways we could flip a coin, there are 2 ways to flip a coin. We could either get heads or tails. And then if we roll a die, there's 6 different outcomes there. And if we multiply 2 times 6, then we get a 12. 12 different ways. So for example B, a paint manufacturer wishes to manufacture several different paints. So the categories include, so we have 4 different categories, color, and the colors are red, blue, white, black, green, brown, and yellow. And we have type, which is latex and oil. And then texture, which are flat, semi-gloss, high gloss, and use, which is outdoor and indoor. And we want to figure out how many different ways we can create these paints. So since there are 4 categories, we're going to put 4 little lines down here to represent each category. So our first category was the color, and there are 7 different colors. So we put a 7 here for the first one. And since we're using the fundamental counting rule, we're going to be multiplying. And we multiply by the number of types. And there are 2 types, latex and oil. So we put a 2 there. And then we multiply by the number of textures, which are 3. So we have 3 different textures. And then the use are going to be 2, the indoor, outdoor. And then if you use your calculator and multiply this, we get 84. So we get 84 ways. So there's 84 different ways to make different paints with these categories. So for example C, so the first year state of Pennsylvania, let me start that again. So the first year, the state of Pennsylvania issued a railroad memorial license plate. The plate had a picture of a steam engine followed by 4 digits. So assuming that repetitions are allowed, how many railroad memorial plates can be issued? Okay, so we're going to be inserting the digits 0 through 9. And so 1 through 9 are 9 digits, and then 0 counts as a digit 2. So that means we have 10 different digits. 10 digits, okay? So the memorial had 4 of them. So then we're going to make 4 categories here. We're using the fundamental counting rule again. So we're going to be multiplying all these digits. So the first digit, it could be any number in between 0 and 9. So then there are 10 possibilities for the first digit here. And then if you read the problem, it says repetition is allowed. So if this was a 4, this one could be a 4 as well. So then you still have 10 different possibilities for here, and 10 possibilities for the next one, and 10 possibilities for the last one. And if you multiply all of that, you get 1 with 4 zeros. So then I got a 3, 4. So this is incorrect here. It should go there. So there are 10,000 ways to make this license plate. All right, so for example D, so a person needs to make a 4-digit combination to open a lock on a garage door. The person decides to use 4 different digits from the first 4 digits 0 through 3. How many different combinations can be made? Okay, so we're going to have a 4-digit code. So we're going to have 4 digits. But in this example, we're not using all the digits. We're only using the digits 0 through 3. And they said it had to be different digits. So if we're only using the digits 0 through 3, so that's 0, 1, 2, and 3. So I'm going to pick one of those digits and go here. So for the first one, we have 4 different possibilities. We've got 4 possibilities here. Now since the digits have to be different, let's say the first one was a 1, then I can't use 1 anymore. So now I don't have 4 possibilities, I only have 3 possibilities. And then since one of the digits got used up, now for the next one I only have 2 possibilities, and then 1 possibility right there. So this is going to be, so if you multiply, 4 times 3 is 12, and 12 times 2 is 24, and 24 times 1 is 24. So there are 24 different possible combinations this person can pick. All right, so for example E, we have, let's see, a radio talk show host can select 3 of 6 special guests for a program. So the order of appearance of the guest is important. And we wish to know how many ways this can be done. All right, we're going to do this in 2 ways. First way, using the fundamental counting rule. So if we use the fundamental counting rule, there's going to be 3 guests. So we have 3 guests. And so for the first guest, we have 6 different options for the first guest. And once we choose the first guest, now we only have 5 options. And then we multiply that by the last one. So once we pick 2 guests, there's only 4. And if you guys use your calculator and multiply, you're going to get 120 ways. 20 ways. Okay. So that's using the fundamental counting rule. And now we're going to do this using permutations. Okay, so when we use permutations, the order is important, and the problem said the order is important, so that's good. So here's the formula for permutations. It's n, p, r, and then the formula is n factorial over n minus r factorial. There. Okay, so in this problem, n is going to be the number of guests. So n, in this case, is going to be 6. And r, so of the 6 guests, we're picking 3 of them. So r is 3. And then again, we use permutations when order is important. Okay, so then if we plug in these numbers into the permutation formula, I'm going to have, let's see, we'll put it right here. So 6p3 is going to be equal to 6 factorial over 6 minus 3 factorial. Okay. All right. So I haven't told you what a factorial is yet. So what 6 factorial means is you're going to take 6 and multiply it by 5 times 4 times 3 times 2 times 1. All right, all over. So we work inside the parentheses first. 6 minus 3 is 3. So this is 3 factorial. And then, simplifying the 3 factorial, we get that we get all of this over 3 times 2 times 1. All right, right there. So if you notice in the numerator and the denominator, you have a 3, 2, 1, and you have a 3, 2, 1. So when you're dividing, this 3 divides out here, turns into a 1. 2 divides out with the 2, turns into a 1. 1 divides out with the 1, which is 1 already. And you're left with 6 times 5 times 4, which is the same as we got using the fundamental counting rule over here, which is our 120 ways. All right, so for letter F, we want to know how many permutations of the letters can be made from the word statistics. So we got statistics up here. So that's all right. So there's statistics. Okay. So what's different from the previous permutations was there was no repetitions of any single person. Each person is different, and so there's only one person. But over here, we have 3 S's that are identical. We have 3 T's that are identical. We have 2 I's that are identical. So then it changes our formula for permutations a little bit. So what you want to do is, so the goal is to figure out how many different ways we could rearrange all these letters. And so what you do is you count the number of letters. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our n is 10. And then we count the number of repetitions. So they use R. So R1 is going to be the number of times that S repeats. And S repeats 1, 2, 3 times. And then R2 is going to be the number of times T repeats. So that's 1, 2, 3. And then R3 is going to be the number of times A repeats. There's only one A, but for the sake of the example, I'm going to put the 1 there. And then R4 is going to be the number of times I repeats. And I repeats 1, 2. Let's see. Did I get all the letters? I need C. So R5 is going to be the number of times C repeats. There's only one C. And we get this here. And a good way to check to make sure you got all the repetitions here is if you add up all these numbers here. And if you add up all the numbers, you should get your n. So if I add 3 plus 3, that's 6, 7, 8, 9, 10. So this is good. That means I got them all. So if I want to count the number of ways, we could rearrange the letters into statistics. So there's a formula. It looks like this. So n factorial all over, and then it's going to be R1 factorial times R2 factorial. And then you keep multiplying until you get to the end. They called it RP factorial. So RP just represents the last repetition there. So for us, we have a 10. So this is going to be 10 factorial right here, all over. So R1 is 3, the number of times S repeats, 3 factorial, times the number of times T repeated, which is another 3 factorial, and then times the number of times A repeated, which is only 1. So you don't really need to put the 1, but I like to put it there as a check. And then we got R4, which is 2, so the number of times I repeats, so times 2 factorial. And then the last one is the C. Again, you don't need to put the 1s, but it's good for the check to make sure you got everything. So if you put the 1s in, just like over here, they had the 10, these numbers here should add the 10 as well. So this is what we got to figure out what it is, right? Okay. So 10 factorial, that's going to be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All over a 3 factorial, 3 times 2 times 1. And then another 3 factorial, 3 times 2 times 1. A 1 factorial, so in this case I'm not going to write the 1 factorials because 1 factorial is just 1. And then times a 2 factorial, And 1 factorial is 1 as well. And let me rewrite the 2 factorial as 2 times 1. Okay. So when you're doing these problems, everything in the denominator should divide out with something in the numerator. All right? So let's see. You have a 3, 2, 1, and you have a 3, 2, 1. So then this 3, this 3, this 2, this 2, this 1, this 1. And you don't need to worry about these ones. The 1 times 1 is 1. It doesn't change anything there. All right. So now you got to figure out how to get the rest of the numbers to divide out. Well, if you take 3 times 2, that's 6. And we have a 6 right here. So then these 2 right here multiply to 6 and would divide out with that 6 there, completely turning into a 1. And now you're left with just a 2 in the denominator. And you could pick any of the even numbers to simplify that. I'll choose the 4. So in this, when we do this, it doesn't divide out all with the 4. You have 2 left over. 4 divided by 2 is 2. So you have 2 left over. So then what you have to multiply is 10 times 9 times 8 times 7 times 5, and then times 2. That is what you have to multiply there. Let's see. So if I do 5 times 2, that's 10. And 10 times 10 is 100. So this is going to be 100 times, let's see. Let's do 8 times 7 is 56. And then we got to times that by a 9. So then if we bring that over here, so this is going to be equal to, so then if we do 56 times 9, that's going to be, so 9 times 6 is 54. So you get the 4 here. You carry the 5. 9 times 6, well, I'll just do it over here. So we're going to take 56 and then times it by 9. Right? Who needs a calculator? So this is going to be 54. And then 9 times 5 is 45. And 45 plus 5 is 50. So you get 504. So what we get is a 504 here. And then times, don't forget that 100. And we get 504, 0, 0, 0. Oops, 1 too many zeros. Okay. So there are 50,400 different ways. Ways to do what? To rearrange the letters in statistics. Seems like a lot of ways to rearrange a small amount of numbers, right? Yeah. Okay. So now for letter G. So we have the director of movie at the park must select 4 movies from a total of 10 movies to show on movie night at the park. How many different ways can the selection be made? All right. So there's one key difference in this example compared to the other ones. In all the other examples, the order was important. In this case, the order is not important. If I pick whatever movies I pick, those are the 4 movies that are going to the park, and it's one of those 4 that will be shown. It doesn't matter which one I pick first. So here the order is not important. And if the order is not important, then combinations is what you got to use. So the formula for combinations is this right here. So again, you only use this one when order is not important. So it's NCR, and it's n factorial all over. So it looks very much like the permutation one, n minus r factorial, just like the permutation one. And then it has the added r factorial down here, r factorial down there. So that's the combination formula there. So in this case, so we have 10 movies to choose from. So n is 10. And r, we're going to choose 4 of our 10 movies. So r is 4. And since the order is not important, we're going to be using combinations instead. Okay, so let's see. The formula becomes for us 10 C4. Okay, so then we have another 10 factorial. So this is going to be 10 factorial all over, now it's going to be 10 minus 4, 10 minus 4 factorial, all over r factorial, so times another 4 factorial here. So first I'm going to simplify the 10 minus 4. So we get 10 factorial all over 6 factorial times a 4 factorial. Oops, factorial. There it is there. Okay, so here we go again. So this is going to be 10 factorial. So factorial means start at 10 and work your way down until you get to 1. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All over, so that's 10 factorial, all over 6 factorial, and 6 factorial is going to be 6 times 5 times 4 times 3 times 2 times 1, and now we have a 4 factorial. So times 4 times 3 times 2 times 1. All right. So this is the bigger one. You have 6, 5, 4, 3, 2, 1. And here's another 6, 5, 4, 3, 2, 1. So every one of those factors divide out with all of these factors down here. 6 over 6 is 1. 5 over 5 is 1. 4 over 4 is 1. 3 over 3 is 1. 2 over 2 is 1. And 1 over 1 is 1. And just like permutations, everything in the denominator should cancel out when you're done. So then we have to do some multiplying here and figure out what goes into what. So let's see. I think the best way to do it is go 4 times 2. So 4 times 2 is 8, and you have an 8 right up there. So you got 4 and 2 divide out with this 8, and you're left over with the 3 in denominator. The only thing that's left that is divisible by 3 is going to be this 9 right here. So the 3 goes into 9 3 times. So you have a 3 left over. So what are we left with? So then again, note everything in the denominator divided out. 1 doesn't matter. So you're left with the 10 times the 3, and then times 7, and everything else went away. So if you multiply this, you get 210 ways. So if you have 10 movies and you're going to pick 4 of them to go to the park, the order is not important in which you pick the 4. So since the order is not important, we're going to be using combinations instead of permutations. And then using the formula, we get down to 210 ways of picking these 4 movies out of the 10. Okay. So for example H, we got a club that has 7 women in it and 5 men. And we're going to form a committee of 3 women and 2 men. And we want to know how many ways this can be done. So this problem is relatively difficult because it takes a couple of things that we learned in this section. So the first thing we got to figure out is the number of ways we can choose the women. So in the club, there are 5 women. I'm sorry, 7 women. 7 women. And there are 5 men. All right. And then for our committee, so I'll put COM for committee. Our committee is going to have, let's see, 3 women and 2 men. And we want to know the number of ways that we can get, the number of ways we can form our committee. Okay, so first we're going to figure out the number of ways we can choose the women. And we're going to use combinations because it doesn't matter the order that you choose the people to be on the committee. Whoever is first, if you were first and chosen on the committee, or if you're last chosen on the committee, it doesn't matter, you're still on the committee. So we'll be using combinations and not permutations. So for the women, we have 7 women to choose from, and we're going to choose 3 of them. So we have 7C3. Okay. And then, so this is going to be 7 factorial all over 7 minus 3 factorial times the 3 factorial, like so. So doing the 7 minus 3 first, you get 7 factorial all over 4 factorial times 3 factorial. And then rewriting the factorial as a product, you get 7 times 6 times 5 times 4, 4 times 4 times 3 times 2 times 1, all over 4 times 3 times 2 times 1 times the 3 factorial, 3 times 2 times 1. So again, everything in the denominator should divide out with something in the numerator. So in the denominator you have 4, 3, 2, 1. In the numerator, 4, 3, 2, 1. So the 4 divides out, turns into a 1. 3 divides out, turns into a 1. 2 divides out, turns into a 1. And 1 with the 1. All right, so we don't have to worry about the 1 because 1 times anything is anything. So you have a 2 and a 3. And if you multiply that, you get 6. And luckily for us, we have a 6 in the numerator. So these 2 divide out with that 6 there. And you're left with 7 times 5. 7 times 5. So then there are 35 ways to choose the women. So this is for the women. Put that up here. Women. Okay. So this is the number of ways we can choose the women. All right, so now we have to choose the men. So for the men, so put men up here. Okay, so again, we'll use combinations because the order doesn't matter. There are 5 men to choose from, and we're going to pick 2 of them. So that's going to be 5C2. All right, so for 5C2, you're going to have 5 factorial all over 5 minus 2 factorial times the 2 factorial. All right, so doing the parenthesis first, this is going to be 5 factorial over 3 factorial times 2 factorial. All right. So then now rewriting the factorials as products. So 5 factorial is 5 times 4 times 3 times 2 times 1 all over 3 times 2 times 1 times the 2 factorial, which is just 2 times 1. Okay, so everything in the denominator will cancel out with something in the numerator. You got 3 over 3 is 1, 2 over 2 is 1, 1 over 1 is 1, and you have a 2 left over, and 2 divides 4. So 2 goes into 4 2 times. And you don't have to worry about that 1. So all in all, we get 5 times 2, which is 10 ways. Okay, so we get 10 ways for the men, and we have 35 ways for the women. So then we want the total number of ways of calculating the number of ways we could get for the committee. All right, so now we need to use the fundamental counting rule. So for the women, there are 35 ways of doing that. And then for the men, there's 10. So if you multiply, you get 350 different ways to form the committee.